Hello and welcome to this lecture on vector calculus. In this video, we are going to solve problems on gradient which comes under vector differentiation. So let's start with the problem. So see here, the first problem we want to find the gradient of the given function pi, where pi is the logarithmic of x square plus y square plus z square. So we want to find the gradient. So what do you mean by gradient? It is denoted by the symbol gradient phi. So this is what we want to find. So here the formula will be dou pi by dou x, dou pi by dou y plus dou pi by dou z, here I vector, here j vector, here k vector. So we want to differentiate this given function pi with respect to x, y, z, and we have to substitute in this formula. This is what we say gradient of the function. So here what we will do on the next step, we will write the formula. Now we are going to evaluate this one by one. First I will find dou pi by dou x. Here the function pi is the function of function, a log of x square plus y square plus z square. Here see, this will be another function. I may consider that is u. So log is a one type of function, and on which that log function we have one more function that we call it as x square plus y square plus z square. So it is a function of function. Now we want to differentiate this whole function with respect to x, but it is in the function of function. We may use chain rule. So it will be of dou, here see, here is a function pi. So dou pi by, let me consider this function, the inner function as u. So dou pi by dou u into dou u by dou x. Therefore, this can be written as log of u, where u is known to be x square plus y square plus z square, where u equal to x square plus y square plus z square. So first I will substitute dou u by dou pi by dou u. Here this we call it as pi. Okay. So I will differentiate this function with respect to u. It will be of 1 by u, and if I differentiate this function u with respect to x, I will get the value as 2x. Here y square, there is no x term, it will become 0. Z square, here also it will become 0. So here it will be 2x divided by u. Therefore 2x divided by, what do you mean by u? U will be x square plus y square plus z square. So therefore this will be dou pi by dou x. So this is what the value I will get. 2x divided by x square plus y square plus z square. Similarly, if I go for dou pi by dou y, so I will differentiate the pi with respect to u first, and I will differentiate u with respect to y. So here, it will be 1 by u again. U will be x square plus y square plus z square. If I differentiate with respect to y, it will be of 2y. Therefore, 2y divided by x square plus y square plus z square. So similarly, this will be the our value of dou pi by dou y. A similar way, I may get the dou pi by dou z. Then we will substitute in this formula. So I have substituted, this will be dou by dou x, dou y, dou z. And we may simplify it still now, because all the terms which carries 2. So all the terms which carries 2. So I may take the value 2 as a common. And also I may take this as a r vector. Let me consider as r vector. Just this is a simplification. This is nf. Up to this is nf. Also we can do a further in a simplification method, that is r. I am taking this as a r vector because it has ijk. So I am taking this r vector, and we know that if I am taking any of vector, if it will be r square, means it will be the square of each term with the sum. Therefore, on simplifying this, this will be the final resultant. Okay, next we go for another problem. A very simple problem. Here the pi is not a function of function, simply a simple function x, y, z. So I want to find the gradient. This will be the formula. Now I need dou pi by dou x. So here I am differentiating x and remaining will be a constant. So the remaining I will get the value as y z. And if I go for dou pi by dou y, here it will be x z. Dou pi by dou z, it will be xy. So these are the values I may substitute directly, and this will be the gradient pi. And also in this problem they are asking to substitute at the point at the final stage. After finding the gradient, we want to substitute this point as x, y, z. So here y will be 2 and z will be 3. So 2 into 3 I vector plus x will be 1 into z will be 3. So j vector plus x will be 1, y will be 2, k vector. So final answer 6 I vector plus 3 j vector plus 2 k vector. 6, 3, 2. That's all. Next, one more problem. Very simple problem. It will be a subcase of the first one what we have discussed. So this formula, I will differentiate dou pi by dou x directly, it will be 2x, dou pi by dou y, it will be 2y, then dou pi by dou z will be 2z. And I may take the value 2 as common, and we may simplify on the next step as 2 xi vector plus 2, sorry, y j vector plus z k vector. Okay, this can be written as 2r vector. It can also be written as like this. And next problem. Here x square plus y minus z minus 1. At last we have to find at the point. So I am just taking this pi and I will go for the differentiations. Dou pi by dou x. Here it will be 2x. Dou pi by dou y. Here x square becomes 0, y means it will be 1. Then dou pi by dou z minus 1, because the remaining terms will be a constant, it becomes 0. Here it is minus z, so it comes minus 1. On the substitution of these value, I will get this as a gradient. And we have to substitute these values for x, y, z. Here the variable is x is alone there. So gradient pi at the point 1, 0, 0 will be 2 into 1. So therefore 2 I vector plus j vector minus k vector. That's all.